Okay, today's date is 5/20/21, and we're going to learn about the Pythagorean theorem. Pythagorean theorem. Pythagorean theorem. Pythagoras, a Greek mathematician, discovered the Pythagorean theorem, and he named it after himself. It's pretty cool. So if you ever invent something or discover something, make sure you name it after yourself. So for generations to come, everyone will know your name. Okay, the Pythagorean theorem has to do with right triangles. This theorem, this idea, only works with right triangles. It does not work with any other triangle other than your right triangle. So I'm going to draw a pretty big right triangle just to illustrate the Pythagorean theorem. And of course, if you have graph paper, it's so much easier to draw a right triangle. All right. Pythagoras discovered that if you add these two parts of the triangle, when they're squared, it will equal this side squared. What? Well, first off, he named them. He called this side of the triangle a leg, this side of the triangle a leg. These two are called legs. The ones that are attached to the 90-degree angle, the ones that create the 90-degree angle, are called your legs. And this diagonal one that's across from your 90-degree is called the hypotenuse. In a right triangle, you have two legs and a hypotenuse. Two legs and a hypotenuse. And then he called this leg A, this leg B, and the hypotenuse C. Okay, so A, B, C. And he discovered that if you do A squared plus B squared, it's going to equal C squared. And he realized that this will work for every right triangle. This leg squared plus this leg squared will always equal this leg squared. Funny enough, it doesn't work when you go A plus B equals C. It doesn't work A plus B equals C. He discovered that you first have to square it. You have to square it first, which is totally weird, but it is what it is. He discovered this hundreds of years ago, okay? And so with this information, with this A squared plus B squared equals C squared, we can solve for missing sides of a triangle. You'll be using this in 8th grade, and you'll be using this in geometry. And I will teach you, I'm going to spend 2 days teaching you this, and you'll be pros. I mean, some of you might have already learned this in Alex. Who knows? All right. Okay, so here we go. I'm going to tell you this is 4, this is 3, and this is C, or X, or missing number, or blank. So I want to know, what is C equal? What is the hypotenuse equal of this triangle? Okay? It's not 7. You can't just add these two and call it 7. Okay? Doesn't work out that way. What we do is we use the formula A squared plus B squared equals C squared. Okay? And number one thing is you have to determine, if this is a different letter, then you have to go, okay, what am I solving for? Well, I'm solving for C, right? Sometimes they label it X, and you're just like, let me take 2 seconds to figure out, am I solving for a leg or am I solving for a hypotenuse? Today, we're only solving for C. On Monday, I'll teach you how to solve for A or B. It's a little different. Now, we know that this is A and this is B. So we substitute. A is 4, so we're going to do 4 squared plus B is 3, so 3 squared is equal to C squared, right? So we do some math. 4 squared is 16 plus 3 squared is 9 is equal to c squared. So then we add these two numbers up and we get 25 is equal to c squared. Now, is c and c squared the same thing? Is my answer 25? My answer is not 25. C does not equal 25. C squared equals 25. I don't want c squared. I want just c all by itself, the letter C. Well, what I taught you yesterday comes into play. Remember yesterday when I taught you square roots? Right here, square roots. And I said, well, 5 squared is 25 with the exponent is 25. So the opposite of squaring would be the square root. If I take the square root of 25, I get the single number 5, right? So therefore, if I want c and not c squared, if I want c by itself, what you have to do is take the square root of c squared, and that will equal c. When you take the square root of c squared, it gives you c. Okay? So remember how we used to do equations when we draw our bars, right? So if I did the square root on this side, guess what I got to do on this side? Yep, you have to take the square root of 25. Kind of like when I told you guys when we first started learning about equations, if you add 5 on this side, you have to add 5 on the other side. If you divide it by 2 on this side, you got to divide by 2 on this side, right? You got to do the same thing on both sides. Here's the same thing on both sides. If I took the square root on this side to get rid of the square, I took a square root to get rid of the square, I got to take the square root on this side, okay? So I took the square root of c squared to get c. Now I'm going to figure out what is the square root of 25. Am I lagging? Yes, 5. I am pausing though. I am purposely like pausing a lot. So it's fine. Just so you guys can process it. I am like, going slower. It looks really hard. It looks like, what in the world are we doing right here? Like, what? But honestly, like the math isn't hard. It looks totally like, what are you doing? And yes, I understand that. But if you listen and try to just understand that, like, okay, this is just, think about it as a typical number, right? Think about it like, you don't have to write this down. If I had 2x equals 10, right? And your goal is to get x by itself, right? So you would divide by 2, x equals 5, right? Like, so this idea of, okay, you want x by itself, so you got to get rid of this. The same idea applies to this. I want c by itself, just c all by itself. So I got to remove this little exponent, right? It's an exponent. It's not a big 2. So in order to get rid of this little exponent, you take the square root of it. That's why we do the square root. Okay? Okay, let's try another one. I mean, I don't expect all of you to be pros right now. I expect you to kind of be like, okay, I kind of see where we're going. Let's do another one to feel a little bit more comfortable. Let's try another right triangle. This is where like geometry and algebra come together because you're solving. 12, 5, and let's call this one x. Maybe it'll be helpful if I call it x. Maybe. All right. So you realize that you are solving for the side that's opposite to the 90 degrees. So the side that's opposite to the 90 degrees is called your hypotenuse. It's called your C, right? The 12 and the 5 are called your legs, and we refer to them as A and B. Now, to be honest with you, you can make either of these numbers A or B, right? The 5 could be A or it could be B. The 12 could be A or it could be B. Those are interchangeable. What you can't, I'll just call it A. No, this one. The one that's opposite the 90 degrees always has to be the letter C or X, whatever. But you're solving for the hypotenuse. So in your formula, A squared plus B squared equals C squared, the C will always be your hypotenuse. The C will always be your hypotenuse. The opposite, because it does matter where you plug these. This one matters. The C matters. These you can switch around, okay? Especially on Monday's lesson. Okay, so I'm just gonna do 12 squared, right? Because I'm gonna make that one the A and that one your B, plus 5 squared equals C squared. Number one mistakes kids do is they'll want to add the 12 and the 5 and then square it. You don't get the same answer. You don't get the same answer. You gotta do one at a time. 12 squared is, if you should know it, 12 times 12, 144. So we're using what we learned yesterday or reviewed yesterday to today's lesson. Taking a break, so I give you enough time to copy this down. Five squared, 25 equals C squared, or you can put an X squared. I don't know how not to confuse you. All right. So first thing is substitute. Second thing is to square them. Next thing is to add them. Okay, we do some simple math. 169 is equal to C squared, right? But you don't want C squared. Yes, that's the answer. You want to take the square root, so I take the square root on this side. Why? Because I want C by itself. Once I take the square root, you're left with C. You get rid of the little 2. This side, you take the square root. Oh, Miss O'Malley, I have no idea what that is. No biggie. You have a calculator that I showed you how to use yesterday. So take those calculators out. You're taking the square root, so you type in the number first, 169, and then you're going to click on the square root symbol, 13. When you take the square root, you're making your answer smaller. It's like kind of like dividing smaller. So if like 169 and you accidentally clicked on the square and you got a bigger answer, you stop yourself and you're like, wait, no. If I'm taking the square root, I should make my number smaller, okay? Just like if you accidentally clicked on the wrong button, okay? Your answer should be smaller. Your answers should be aligned to these numbers. You see, it's like 5, 12, 13. So this is equal to 13. So this measurement is 13. Your number should kind of be within like a general area. Like if I had 3, 4, and all of a sudden I got 500 up here, it's like, no, wait, this is 3, this is 4. How can this be 500? I must have clicked on the wrong button. All right. Try to do this one on your own right now, just to see if you guys can solve it before I show it to you on your notes. See how comfortable you feel, or where do you get stuck? So try doing it before I send you completely on your own. See if you can, plug in the numbers, square them, and then take the square root. So hopefully you were able to do a squared plus b squared equals c squared. A is 9 squared plus 12 squared equals c squared. So 81 plus 144 equals c squared. Whatever needs to be done on a calculator, do it on a calculator. If you need to add these on a calculator, add these on a calculator, whatever. Right? You're not done right there. You're 100%. I'm hoping that all of you got to like this step, right? Up to here, it's very common math. You're just squaring the numbers and you're adding. Very easy. This, from here, you might get some kids who are like, what is she doing? Just taking the square root. Taking the square root, because I got this little square. Got rid of it. C. So the square root of c squared is equal to c. The square root of c squared equals c. Very, very, very algebra, in which we're just dealing with letters. But mathematically, it works. And the square root of 225, if you don't know, use your calculator. 225 square root 15. Feeling okay?